Good day, grade 10s. Well, this is your favorite uncle. Well, seeing you for the first time this year. So if you haven't subscribed, please just make sure you are part of the family. And today I want us to actually start looking at exponents. Right, let's quickly remind you about the laws of exponents that you probably would have learned in grade 9, right? Things that we should know that we are going to apply, but we're going to actually do a little bit more so that you can actually apply these laws. Now, first of all, let's talk about just the words around so that we know what we are referring to. So usually when we're dealing with exponents, we've got what we call our base, and we've got our exponent. So let's say this is going to be what we refer to as the base, and this is referred to as the exponent. Okay, so we usually say we are raising a base to an exponent, right? And once we have done that, we know that the entire thing is referred to as a power. Now, please, I want you to note, we usually use this word in an incorrect manner. We say 2 to the power of 3, but in actual fact, the entire thing, if I raise 2 to the exponent of 3, in this case, this entire thing is actually a power. But nonetheless, I know that we usually make that mistake. So please, if I gravitate towards that at some point, please don't worry. Okay, let's just get into it. Now, let's talk about the laws of exponents. Right, so in terms of the laws of exponents, we've got in essence about 5 laws, right? And I am going to give you the laws, and I'm also going to give you some definitions. So we say that if bases are the same, so if I've got bases that are the same, and I am multiplying in this case, then what happens? I'm going to add the exponents. So I'm going to have m plus n. Okay, right. I'm going to just switch this guy off because it gives us a little bit of an issue. Right, so this is law number 1, right? So when I've got similar bases and I'm multiplying, in this case, the powers, so I am going to add the exponents. So that's the first law. So for instance, if I've got 2 exponent 3, right, multiplied by 2 to the exponent, let's say 2. So what do I know? My bases are the same, right? And I'm multiplying the powers. So in this case, this is going to be 2 and 3 plus 2. And so this will be 2 raised to the exponent 5. Okay, so that's how we are going to implement that law. Now let's go to the second law. So we say that if our bases are the same and we are dividing, please keep that in mind. Now we are dividing. So what do we do? In this case, we're dividing the powers and our bases are the same. So we are actually going to subtract the exponents. So that means that in this case, I can write this in another way and say a over a to the exponent m raised to the exponent m divided by a raised to the exponent n. That will simply give me, right, a to the exponent m minus n. Now I want you to note that the exponent that is in the denominator will always change sign, all right? So let's take another example. So if I had x cubed divided by, let's say, x squared. So what am I going to get in that case? I'm going to say, well, that's going to be x raised to the exponent 3 minus 2. And so that will give me x to the exponent of 1, right? So I will get x as a result. Now, I want you to note very well, supposing that I was given, let's say 2, okay, let me use a different base. Let's say 5 to the exponent n, right? Divided by 5 to the exponent minus m. I want you to note, ladies and gents, that because I am dividing, what is this going to be? So this would be 5 exponent n, right? Minus, now note I am subtracting a negative m, okay? So I am subtracting what is in the denominator in this case, and what happens to it. You see that what was negative will now change sign. Remember, negative times a negative will give me a positive, so I end up with n plus m. All right, now let's go to the next one, the third law. So we said bases are the same and we're dividing. The exponent in the denominator will change sign, or in this case, I will always subtract. So let's take the next one, right? So if I have a raised to the exponent of m, and I raise all of that to an exponent n, okay? So in this case, what do I have? Right, I know that they will actually multiply. Now, ladies and gents, please don't confuse this first law, right? I am multiplying powers here, whereas on this one, I am actually raising a power to a certain exponent. So if I'm raising a power to an exponent, in this case, I am going to have m multiplied by n. So please, I want you to note that will actually raise the other exponent. So let's just make an example very quickly. So if I've got x to the exponent 3 and I say that is squared, that will simply give me x to the exponent of 3 multiplied by 2. And so this will be x to the exponent of 6. Okay, so please note that again. Right, so let's take just another one. I want us to note in this case. In fact, before I even go on to the next one, suppose if I had x cubed and y squared. I want you to note, if I were to raise them to the exponent of 2, note that the one that I raise it with will actually be applicable for both of the exponents. So what am I saying? This will be x to the exponent of 3 multiplied by 2, y to the exponent of 2 multiplied by 2. So that exponent multiplies into all the exponents that are there in your bracket. So this will be x to the exponent of 6, y to the exponent of 4, right? But I want you to also keep in mind, so in this case, if I've got 2x raised to the exponent of 4, and I raise this to the exponent of 2, right? I want you to note in this case that we will have 2 squared. Now, please keep that in mind. We have a 1 there, so that will be 1 multiplied by 2, and so that will give me 2, okay? And x will also be 4 times 2, and so my answer will be 2 squared is 4, and x to the exponent of 8. Right, so I am going to move on from that one. Let's go to the fourth law. Again, if I am dividing, let's say, so let's say a over b, and we are raising it. So let me say a to the power m and b to the power of n, and I raise them to the exponent of c, right? Please, ladies and gents, I want you to note this will simply be a to the m multiplied by c, and in this case that will be b to the exponent of n multiplied by c. Note that this exponent will be multiplied by the exponents both on the numerator as well as on the denominator. Right, so let's take an example again. So if I say this is 2x squared, in fact, before I even apply those, let's say x to the power 4 divided by 3 to the power of 2, all right? And I raise this to to the power of 2. What does this become? That becomes, in this case, we've got x, that's 4 times 2, divided by 3. This is 2 times 2. And so our final answer will be x to the power of 8, or x raised to the exponent of 8, divided by 3 raised to the exponent of 4. And of course, you're more than welcome to actually write this out as it should. Right, 3 to the exponent of 4, that gives us 81. Right, so that's our answer. Right, so in this case, that is the fourth law of exponents. Right, now, on the last one that I want us to actually touch on. Right, now remember, we've talked about multiplication, we've talked about division rather. Now, on the fifth one that I want us to please remember, we've kind of already spoken about this, right? So we said if we are raising an exponent to an exponent, right, we are simply going to simply multiply, right? So I'm going to actually take some, in fact, before I even continue with that, rather let's talk about the rules. Right, let's talk about the rules. Something that I want you guys to remember, in fact, now before I get to the rules, sorry about that, something of the fifth law that I wanted you to actually keep in mind is that whenever I say, right, a to the minus of m, right, this will simply give me 1 divided by a to the exponent of m. All right, so whenever I've got an exponent that is negative, right, I can simply divide it, or rather write it as the inverse of that exponent in fraction form, right? But this time it changes sign. So that means that if we've got, let's say, 2 to the exponent negative 3, we can write this out as 1 over 2 to the exponent of 3. And of course, the other way is also true. Also, just something that I want you guys to keep in mind. Let's say I've got x divided by y raised to the exponent of negative 1. What would this be? This is the same as y over x, okay, raised to the exponent of positive 1, okay? Right, so in this case, that would be me applying the very same rule again. Right, now, let's talk about the rules, okay? So, what do we note about the rules? So, firstly, the first rule is that anything raised to the exponent of 0 will be equal to 1. Please note, in this case, anything raised to the exponent of 0 is 1, but I want you to keep in mind, we cannot say 0 to the exponent 0 is equal to 1. Actually, 0 to the exponent of 0 is undefined. Okay? So this would be undefined. All right? Now, let's talk about the second rule. Now, the second rule in this case looks more like something that I have already stated. In this case, I said whenever we've got a negative exponent, so if I've got a to the exponent minus 1, right? So note this is 1 over a. And even the opposite is true. So in this case, anything to the raised to the exponent minus 1, I will actually have 1 over a to the exponent of 1. Right, so thirdly, what is my other rule? Okay, I can write this way. If I've got y to the minus m, right, I've already shown you that we can write this as 1 over y to the exponent of m. Or in this case, I can simply write this as 1, okay, and please I want you to note, I can write this as 1 over y raised to the exponent of m. Remember, the rule is 1 raised to any exponent will still give me 1, right? That's very important. 1 raised to the exponent anything, right? That will still give me 1, okay? Because 1 times 1 times 1 is 1. It doesn't matter how many times you multiply 1 by itself, it will always give us 1. All right, I hope that's clear, ladies and gents, and we are now going to try and implement some of these laws, right? I want us to take a couple of exercises that we're going to do together, right? And as we do these examples, please just note anytime that you've got an issue, we're going to try and implement this as much as possible. Right, so let's take a couple of exercises. All right, so let's take the first one. So suppose I've got x cubed y squared times z, okay, multiplied by x times y squared times z cubed. Okay, so now we are multiplying. So let me just do this. We are multiplying these two. Now remember, we are going to multiply the bases that are the same. And what do we know about our first law? Our first law simply says, if the bases are the same, where are the bases that are the same? So x and x, right? What do? We add the exponents. So this is going to be x to the power 3 and x to the power of 1, or rather x raised to the exponent of 1, right? We can do the same with y. So that's y2 plus 2. And z, we are going to have z1 plus 3. And so what do we do in this case? That's going to be x4, y4, z to the power of 4. If you really wanted to be pedantic about it, we can actually write this as x, y, z, all of them raised to the power 4. Remember what we said in this case, if we can raise to the exponent 4, it means that we will do this for all of the different bases. Okay, right, now quickly let's go on to the next one. All right, so if I am given, right, we're going to take just a couple more exercises, right? So if I've got x squared over y, and all of this is raised to the exponent of 3, right, what do I have in this case? I'll have x, 2 multiplied by 3, divided by y, 1 multiplied by 3. And so, in this case, that will give me x6 divided by y3. Right, so that's how I will write it. Of course, in this case, there are other ways in which I can write this down, but I am going to leave it in that format for now. Right, now let's take another example, okay? So if I take 2 to the exponent of m plus n, right, divided by 2 to the exponent of n minus 1, okay? Right, what are we going to do? The bases are the same, right? So this would be 2 to the exponent of m plus n. Now note, the bases are the same and we are subtracting, right? So we're going to subtract what we had in the denominator. And in the denominator we had minus n minus 1. Right, so what does this do? This becomes 2m plus n, Right, now the negative will multiply into the bracket. Negative 1 times n, that will give us minus n. And negative 1 times negative 1 gives us positive 1. Do you notice what has happened to these? They have changed sign. Can you see that? Right, the one that was positive became negative. The one that was negative became positive. So whenever we are dividing, the exponents change sign. Right, so what do we notice? The n and minus n cancel out. So we've got 2 raised to the exponent of m plus 1. Okay, right. Now, I want us to take a couple of exercises, and we're going to be continuing with a whole lot more of these. I just wanted us to take one that's a little bit maybe on the challenging side so that we can see how to go about that one. And in our next lesson, I'm going to make sure that we do a little bit more of these, right? So that we are able to see how to implement them. Right, so let's take another one. Okay, so supposing that we've got x squared to n minus 1, right, and we're going to have x cubed y into minus 2n times x squared divided by xy to the power minus 3 n and y to the minus n. Now, ladies and gents, remember, what's the first thing that you're going to do? I want you to try it out on your own, pause the video and work it out, and then check your answer. And then once you've done so, please just unpause the video and look at the one that I have. Okay, right. Now, I hope you've paused the video, you are done with it. So let's have a look at what we're going to have. So now we know that when we raise an exponent, there's the 2 there, to another exponent. So what happens in the first one? We've got x, that's 2 into n minus 1, right? Remember that 2 multiplies into the exponent that we raised that with. So this is multiplied by x cubed, or rather x cubed, but we multiply that by negative 2n. Okay, y 1 multiplied by negative 2n, and this is multiplied by x squared, and this is divided by, right? Now we've got x, remember we've got a 1 here, so that's 1 multiplied by negative 3n. We've got y, and 1 multiplied by negative 3n, right? And we've got y to the power, or to the exponent of negative n. Now let's quickly have a look at it, right? Oh, my battery is almost gone. So in this case, I've got x, right? Remember our distributive law, okay? Right, that's 2 times n, that will be 2n. 2 times negative 1, that's going to be minus 2. And we've got another x, 2 times negative 3n, that's going to be minus 6n. That's going to be y minus 2n. And this is x squared divided by x to the minus 3n, y to the minus 3n, and we've got y to the minus n. All right, now let's group all the bases that are the same. Please, I want you to follow me in this. Right, so we've got bases that are the same. We've got 2n minus 2, right? Minus 2. We said if bases are the same and we are multiplying, we add the exponents, right? So that will be 2n minus 2. That's minus 6n. and we are going to add the 2 again over there, right? So I want you to see it nicely. Okay, so I'm taking that minus 6n, taking that plus 2, and I've added them there. Right, but now you keep in mind, we also have divided by the minus 3n. So we said now, if we are dividing, what happens to the exponent? The exponent changes sign, right? That will be minus a minus 3n. And so that will give us positive 3n. I hope you understood that, grade 10s. Right, so now I'm going to take y. Right, so here's the first one. That's minus 2n. That's the exponent. But now I've got another exponent here, which has a minus 3n. But remember, it is divided in this case. So what happens? The exponent changes sign. That's plus 3n. And we've got 1 with a minus n. What happens? The exponent changes sign, and that becomes positive n. Right, now let's try and do our algebraic sums. So we've got minus 2 and positive 2, they cancel each other out. Okay, and we've got 2n minus 6n plus 3n. So if you take all the positives, 2n plus 3n will give me 5n minus 6n. That will give us x to the minus n, okay, and y. In this case, we've got minus 2n plus 3n, which will give me positive n, plus n, that will give me positive 2n. Well, we can leave it in that format, and nothing wrong with that. If you really wanted to be to have only positive exponents, now you remember, if we've got x to the minus n, we can write this as 1 over x to the exponent n multiplied by y to the exponent 2n divided by 1. And so that will be y to the exponent 2n divided by x to the exponent of n. Now you don't need to have done this all the way through, right? You can give me something that looks like this answer that we had over here. All right, not unless the examiner says you need to give that as a positive, right, exponent. Right, so here's what I want you to do for me, grade 11s. I want you to give me an answer. This is the last one, and I want you to give me an answer to it. So I've got 2 to the exponent 2n minus 1. And I've got 2 to the power of 2n plus 2 multiplied by 2 divided by 2 to the exponent of 4n. Please give me an answer to it, okay? Please write the answer in the comments section and let me know what you get. Well, we're going to come back with some more exponent questions, but for now, I will see you guys again next time. From me for now, it's sharp sharp.